this is the most advanced robot which is being built in India. I'm co-founder and CEO of xTerra Robotics. We are building an autonomous legged robotics company, started with building lab prototypes, and then we saw a clear gap in terms of no deployable robots in India. The initial years of even before starting xTerra Robotics, this being a research project, it started with support from DRDO. At that time, with the funding of DRDO and with support, we established Mobile Robotics Lab here, and it wasn't even existing before that.
Okay.
So we established the lab. We started building lab prototypes. During our early years, as an xTerra has been mostly bootstrapped, which is also shocking at many a times. That being a company which is building hardware, building software, building the complete full stack solution, we have been bootstrapped, again with the support of some of our early customers.
So you guys were generating revenue from your first year?
Yes. Then the idea was already clear in terms of starting from a lab that we will commercialize this robot, which is a four-legged quadruped robot. There are Chinese players who have sold the robots, but they are not able to do useful work in India because they have not provided a full stack solution. The core part of these robots, and when I talk about hardware, is the actuators. If you see these kinds of robots, as in legged robots, how they are moving is they have multiple joints. In this robot, a quadruped robot, which is able to move in any direction, it has 12 number of joints. These 12 joints, these are providing the forces and the torques, which allows the robot to hit the ground how we walk, right? We hit the ground, we fall forward, and then we walk. So that is one of the critical, let's say, hardware components which we have researched, which we have patented in India, and which we are continuously working to make something which is not being built in India or in the world.
So is it fully autonomous?
So currently the robot which you are seeing is a basic version which has no external sensors like cameras or lidars. We have different versions with different sensor mountings on top, which allow these robots to move autonomously. We have performed autonomous operations, particularly in one of our early industrial pilots. But the robot which you see is at times remotely teleoperated, and it can be sent to a particular location with a pre-mapped location, so with a pre-mapped area.
How do you see the role of generative AI in this? Like, is it going to unlock the full potential of robotics maybe in future?
Yeah, it is doing it. With the advent of generative AI, now it is becoming more tractable.
Hello everyone, welcome back to another episode of the Rocket Media. Today I am at IIT Kanpur with Aditya. He is founder of xTerra, a robotics company incubated at IIT Kanpur. Swagat hai Aditya, glad to sit in front of you.
Thank you for having me.
Okay, so firstly tell us about your startup, what you are building here at IIT Kanpur.
Okay, so I'm co-founder and CEO of xTerra Robotics. We are building an autonomous legged robotics company from ground up. This is something which started from a lab project here at IIT Kanpur. Initially, this work started with building lab prototypes, and then we saw a clear gap in terms of no deployable robots in India. Seeing that, I, along with 4 other co-founders, started xTerra Robotics to cover the gap and build capable legged robots which are navigating in all kinds of terrain.
Okay. So you're always into hardware, like from your college days, like you're always into robotics?
I was always into hardware, is what I can say. During college, I was involved in motorsports team.
Okay.
So during my 5 years here, so I was part of a dual degree program in mechanical engineering. During my 5 years, we had built 5 different cars. All types. One was Formula Student, the other was Baha, which is an all-terrain vehicle, and then even later I was mentoring team which was building Formula Electric, which was the first Formula Electric car built in IIT Kanpur.
Okay.
So majorly I was around automotive and hardware manufacturing throughout my college days.
And what after college?
After college, as in working with automotive cars and partially starting with some robotics, I joined Jaguar Land Rover. So that was probably what based on my background, it was the perfect place to start with. I joined as a control engineer there, worked on autonomous vehicles, and I spent almost, as in, I worked there for close to 3 to 4 years, majorly in India, but also been part of their team in UK.
It seems like cars used to fascinate you a lot.
Yes.
So how did you landed upon robotics?
So I personally don't feel much difference in terms of, as in when I was working with autonomous vehicles, it is a mechatronic system which is moving and behaving as in have its own characteristics. And similarly, robots, which being even wheeled robots or legged robots, this was kind of a similar platform. I didn't find much difference, even a jump in terms of moving from autonomous vehicles to autonomous robots. One thing which was more exciting towards legged robots was it was more challenging. As in, the autonomy problem is kind of similar, but the problem in terms of locomotion and how these robots navigate harshest of environments, that is quite intriguing, and many of those questions are still not yet solved. So
Okay.
that led me, along with other founders here, to start this up.
Okay, perfect. So how exactly entrepreneurship came into your life? Like you were working in a corporate sector.
Yes.
So like it came out of frustration or you met some good, very exciting people, and how everything happened here at IIT Kanpur, how you met your co-founders, how this journey began.
Okay. So it was all based on luck, I would say.
Luck, okay.
Yes. So I started this work, in legged robots, which was a beginning of finding a difficult theoretical problem to start with. I was working with Professor Shakti Gupta from mechanical engineering here, and Professor Mangal Kotari in aerospace engineering.
With your job?
No.
Okay.
So when I started working on legged robots, initially during my college years, I was working with Professor Shakti Gupta and Professor Mangal Kotari, and we were looking at problems which were interesting and difficult to solve. We were in touch with defense labs in Pune. So, and both the professors have a good background working with DRDO as well as industries. So we chose this problem along with, as in closely working with DRDO, and started solving the initial parts, as in building things from ground up. Towards the end of my graduation, as in I was leaving college, I took a job, but I was always intrigued because many of the things were still unsolved. So when I left, there were other students who continued my work here at IIT Kanpur. Next graduates, next PhD students continued, and they picked up some momentum. I was always in touch because we started this new research in IIT Kanpur at around 2019, 2020. So they picked up this work, and they were they were energetic by themselves, and they started building things. That pulled me in a way back to building these robots and commercializing it. They were majorly focused on research, but my idea of coming back was, yeah, definitely we have a hard problem in hand and we can commercialize it, seeing the gap in India. So that pulled me back to IIT Kanpur, and we started working on it. In no way the job at JLR was Jaguar Land Rover was not interesting or not exciting enough, but this was definitely more exciting and challenging.
Okay, so you're always in touch with your professor, and okay, so you're 5 co-founders.
Yes.
Damn. And even professor is your co-founder, which is the case we don't see a lot in India.
Yeah.
So that is itself very great. So if you can talk about that bond and the roles and relationships between you guys.
So since all the activities around the research, and as in we are more of research heavy company. This is a Deeptech project, and we need to build things from ground up. We need patience.
So everyone is passionate about tech and everyone knows tech?
Yes.
Okay.
All 5 co-founders are technically inclined, but as in at this point they are looking at different roles across as in business, finance and legal, but all are technically inclined. And especially talking about the professor, so Professor Shakti Gupta, he's not a more of a traditional professor who has spent all his years in academia. He spent close to 16 years in DRDO as a scientist, worked in practical problems, industrial problems. and then he moved, given an opportunity, he moved to IIT Kanpur in around 2013. So he has been close to industry and practical problems throughout. And with him, I started working on some projects during my bachelor's here. And then we continued this bond to start a new project. So this was something which we started afresh. And then at this point, I would say the kind of relationship between us is more of an equal, because as in we both are learning in a way. It's not that as in we have worked in this field for decades or so. This is something which we both learned together.
Okay.
We started tearing apart problems and solving it through first principles approach, and then we started building components in-house. So the relation has been more of an equal and not more of a student professor role.
Okay.
And similarly, it is with other co-founders who have been ex-PhD students or PhD dropouts from IIT Kanpur. So all are academically inclined, but are passionate about robotics and practical applied problems.
Okay, perfect. So like when you came back and you guys started working on this, so like this is one of the best tech labs that I have seen so far. Like
Okay.
it is really good. So how like you arranged everything at IIT Kanpur? How this funding happened, and like were you guys prepared for like long-term cycles?
Okay.
So tell me about that.
So so the initial years of, even before starting xTerra Robotics, this being a research project, it started with support from DRDO.
It started when?
So it started as in around 2019-20 when I was leaving IIT Kanpur.
Okay.
The work started at that time, but the funding and all the support from DRDO came around 2022.
Okay.
So just around after the after Corona. So at that time, with the funding of DRDO and with support, we established Mobile Robotics Lab here, and it wasn't even existing before that.
Okay.
So we established the lab. We started building lab prototypes, and all the initial research work has happened in the lab, which as in later xTerra spun off from this lab to start commercializing it. And during our early years, as an xTerra has been mostly bootstrapped, which is also shocking at many a times, that being a company which is building hardware, building software, building the complete full stack solution, we have been bootstrapped, again with the support of some of our early customers.
So you guys were generating revenue from your first year.
Yes.
Okay, so like when you started thinking and researching on this project, so what was the first payment you were looking forward to? Because we'll make this.
Okay. So as in we were building, as in we started with a four-legged project, as in
Okay.
four-legged robot project.
So you're clear from the starting.
We are-
Okay, we will
yeah.
build this.
Yes, yes.
Okay.
So this is something which, as in one of our early robots were built in a similar platform, and then we were focused on, as in the idea was already clear in terms of starting from a lab, that we will commercialize this robot, which is a four-legged quadruped robot, and we will be using it across various applications. Initially, initially we weren't clear whether there is a market in India, and we were seeing good enough market outside India, but Indian market, it wasn't even existing at that time, around 2022, 23. So at that time we started, despite as in still unaware of any market building in India, and focusing on building the product and getting customers initially, as in we were in touch with customers outside of India like Singapore and others, which are already advanced in using these robots. So that was the starting point. But as we moved along our path, we got our first customer and we delivered our first robot within 6 months of starting.
Okay.
And with their support, with 100% advance from them, we were able to build our next versions of robots. So this has been the journey. And then the cycle continued for next orders, and we were mostly operating with the profits obtained from the revenues.
Okay, so we'll talk about the market.
Yeah.
But so this is your core product, right?
Yes.
Okay, so what was the first prototype used to look like?
Okay.
And since then, how the journey has evolved from your lens,
Okay.
and how you landed upon this product?
So the core part of these robots, and when I talk about hardware, is the actuators.
Okay.
These are the joints which allow so the joints attached to each links, right? So these are the core parts. The first prototype which we had built, the torque of the joint was roughly 3 Newton meters.
Okay.
So that is the amount of torque a single joint can apply. And the robot, we had created a smaller version which was not even able to lift its legs. So it was not able to maintain balance or able to lift its leg confidently in a way. So that was the first version, which again, it was our starting point for building our in-house actuators. Then, based on the same technology, we increased the torque from 3 to 12 Newton meters without increasing the weight of the joints.
So for layman, like if you can just explain us, okay, how practically, like what does this means?
Okay.
And how it it process it works.
Okay. So if you see these kinds of robots, as in legged robots, how they are moving is they have multiple joints. In this robot, a quadruped robot, which is able to move in any direction, it has 12 number of joints.
Okay.
So there are 12 identical joints present in this robot, which allows this robot to move even below an obstacle, over an obstacle, and in any direction. So more like a crab motion if you have seen for a vehicle. So these 12 joints, these are providing the forces and the torques, which allows the robot to hit the ground how we walk, right? We hit the ground, we fall forward, and then we walk, right? Similarly, these robots are continuously hitting the ground, and how much torque authority is what we say we have, it is able to maintain balance even given the disturbances.
Okay.
So torque and the weight of these joints. So what we critically consider is optimizing torque to weight ratio of these actuators. We need to have maximum torque, as in maximum muscle power, let's say, with minimum weight of the joints itself, so that it can carry maximum payload. So that is the idea. We are able to generate enough torque and while minimizing the weight. So this is one of the lightest robot. You are seeing a 11 kg quadruped robot with 12 of those joints, each delivering a torque of 12 Newton meter, which is continuously hitting a ground, almost 4x our previous prototype, and only 2 kgs weight increase from our previous prototype. So last was 9 kgs of robot with 3 Newton meters of torque, wasn't able to move perfectly. Now with just a slight increase in weight, we are able to deliver more torque.
Okay.
And this is possible with our compact actuators. As we move forward, right? As we move forward in terms of capabilities and using these robots for higher payloads, we are building actuators, these joints, which are able to deliver 10x more torque, as in from 12 to 120 Newton meter, while only increasing the weight 2x. So almost 5 times increase in torque to weight ratio of these actuators.
Okay.
That would allow these robots to be more agile. So they will be able to move fast. They would be able to carry more weight. So that is one of the critical, let's say, hardware components which we have researched, which we have patented in India, and which we are continuously working to make something which is not being built in India or in the world.
Okay, perfect. Thank you so much for making me understand. So is it fully autonomous?
So currently the robot which you are seeing is a basic version, which has no external sensors like cameras or lidars. We have, as in different, from the same base version of the quadruped, we have different versions with different sensor mountings on top. So you can mount a camera, a lidar, and even a pan-tilt zoom camera to observe things.
Or weapons.
Or weapons, or arms, right?
Okay.
So these are all the sensor mountings on top, which allow these robots to move autonomously. We have performed autonomous operations, particularly in one of our early industrial pilots. But the robot which you see is at times remotely teleoperated, and it can be sent to a particular location with a pre-mapped location. So with a pre-mapped area. So we are working towards higher levels of autonomy, as in I'm coming from a background of autonomous vehicles.
Right.
So there are in automotive sector, there are various levels of autonomy. So if you already have a map, you just have to give a target location and it moves, and it is not exploring the area.
Okay.
Right? So that is low levels of autonomy. But when you have unmapped areas, which is would be a common case when I move into unknown buildings with these robots. That is higher levels of autonomy, which require significantly more intelligence in a way that it is mapping as well as it is exploring the area and then finding its location. As in one of the cases which we continuously are looking forward for exploration is, let's say, a hostage situation, right? So in this, you don't know as in where the hostages are located. You don't know the building. It is not pre-mapped. So these robots are continuously, as in creating a map, exploring areas. As in you enter one room, you find nothing. You then find a way back to its gate, enter another, find it, and nothing is being pre-mapped. What you see, a low level of autonomy, which we are using in industries at this point, that is already available with our robots,
Okay.
is you already define number of points.
So, okay,
which the
like from
robot
A
has
to
to
B.
take. A to
So,
B.
like just feed the data, like go
And
from
A to B map is
Okay.
already available.
Okay.
So you are just sending, as in it is able to sense any dynamic objects or obstacles that are coming in the way, which it evades
So
through.
if even if we disturb it, or like we can create obstacles in between, so it
Yeah.
will go to from
It will,
point A
yeah.
to B. A to B. In all geographies, like any trains, like it can go.
Again, so mostly it has been tested on
Ground.
2D or
Okay.
indoor terrains. And outdoors, you don't get as in good enough quality of features to localize and to find a way, right? Usually, you would depend on GPS outdoors. Indoors, you can easily create a map and then move around, but outdoors, you won't have, as in you have a flat ground, long grounds, right? You don't know where you are until you are using GPS. So that is something, outdoor autonomy is something which we have not extensively worked now, but something which I've worked in autonomous vehicles, which we would integrate for applications when deployed outdoors.
Okay. And Aditya, like when you talk about higher level of autonomy,
Yeah.
so how you are going to train this, how you are going to feed the data into this, like we can talk about that.
Okay. So starting with, so considering first is a pre-mapped area and we are
Okay.
going point A to point B, that is, as in that is classical methods. Classical methods are available to allow these robots and mostly based on algorithms which are available. Exploration is something which is, as in more of, as in the robot is making its own decisions, and therein the robot needs knowledge of what is a good move in a particular scenario, right? Wherein you need lots of data to understand what would be a good strategy to move around something, compared to as in when you especially encounter an unknown situation. So we are collecting lots of data, and that is something which we would train models based on, mostly behavioral models, which would allow these robots to make better decisions based on trained data. That's what would be missing there, right? There are not much, as in there could be unknown scenarios, and with advent of recent large models, it is now possible. It is now more possible to use just the contextual knowledge of what the scene is. As in, if there is something approaching you, do you have to back off or you have to move a certain way? You can easily convert it with the description of the scene to find a path that is relevant, which was not, as in which was not easily possible before LLMs or language models.
So how do you see the role of generative AI in this? Like, is it going to unlock the full potential of robotics maybe in future?
Yeah, it is. It is doing
Okay.
it. So robotics and AI now, as in few years back, almost 5 years back, we wouldn't have seen capable robots which are moving in all kinds of terrains and not fine tuned for each kind of scenarios, right? We have more of fixated models for each scenario. We are as in, I won't say over engineering, but we are building models for, let's say, a construction site, now building model for a industrial oil and gas industry, or a different site, and all those are, as in, human engineered. We want something which works for all kinds of scenarios, and that is where large data and large models are coming into picture. And that is how, as in, this is making robotics problem more as in a way feasible and tractable. Until now, as in we were looking into multiple ways to solve higher levels of autonomy or using these robots in real work, right? It was not completely solved, and it's not completely solved yet. But with the advent of generative AI, now it is becoming more tractable,
Right.
and we can use better understanding, better as in large foundation models to understand and to find ways, as in find answers to many unknown edge cases of autonomy as well as movement. So one concept which we actively use is reinforcement learning. You might have studied part of it, and as in it's coming from psychology. So you give rewards to a robot if you give rewards to an robot if it is doing what you are telling it to do,
Okay.
and it is learning by trial and error, right? So now you are continuously uh, learning from different scenarios. You are building multiple scenarios, so it is a combination of simulation where you can create thousands or lakhs of scenarios in simulation and allow the robot to take actions in those environments. You are learning what the robot is doing, as in you are seeing what the robot is doing, you are rewarding it or you are penalizing it based on the action it is taking in the simulation environment, and then based on that you are learning how to operate in lakhs or millions of different scenarios.
Right.
So now with the possibility of running 10,000s of simulations in parallel, and with the possibility of creating scenarios and using reinforcement learning to uh, train these robots in a way to act in the real world, it has become more possible that we are able to deal with scenarios which are unmodeled in a way. So let's say a situation like you find a slippery surface. These robots, they will, as in similar to us, as in if we go through a slippery surface, there is a chance of a fall, or you have to adapt quickly, right? Or there is something that falls over you. So there is again a disturbance which you have to adapt. So all those can be modeled in a simulation, and you are training a robot. You are training a robot which is capable of handling all the uncertainties, which is not modeled, in any way, and you are able to navigate and do all kinds of actions just from learning from simulations.
Okay.
So that is something which again it is part of learning, specifically a field of reinforcement learning, which has made this problem more tractable in a way that I can use these robots in all kinds of environment, and I don't have to fine tune it for every scenario.
Okay, perfect. And Aditi, talking about your peers and competitors, where do as compared to other foreign countries or US, like everyone is saying, ki cutting edge is developed in US.
Yeah.
So like if we compare to them, what is their skill and on which skill we are operating?
Okay.
If you can talk about that.
So there are players which are existing in legged robotics space since as in 1990s. So
1990s.
yes.
Okay.
So and majorly all the players, as in all the global players, are coming from a research lab, including us. And MIT's leg laboratories gave birth to Boston Dynamics, which is the first as in legged robotics company which have commercialized. But given that they started their research work in 1990s, they commercialized their first robot around 2020.
Okay.
So there has been a significant research and their work in closely with defense, but the commercialization stage of these robots, so you can see the depth of work that has gone into as in making these kinds of technologies more feasible. And definitely it's not that we are rewriting or we are recreating everything what they have done over the more than 2 decades, right? So since 2020 they started commercializing it and they started utilizing those robots, and same is the case with as in few Chinese startups and Swiss startups which had started working since as in they've started working after 2010. Majorly every other company started around later than 2010 or roughly around that time. So one of the major differences is, as in few problems we have been trying to solve from ground up, and we have built the technology so that we have control of what these robots are capable of. Out of all the available robots in the market, as in which are actively being used, and there are very few which are able to carry significant payloads. Even as in more than 90% can't carry less than 15 kg payload. So can't carry more than 15 kg payloads. So we, with our actuator technology, can work towards that and target a market which can carry from 50 kgs to even 100 kgs of payload.
And it is patented, right?
It is patented, and we are, as in that was long back. We are piling up patents in terms of our next versions of actuators and next to grow in terms of, as in the capabilities and the what we call as the torque density of these actuators. So that is continuously being improved, and at this point I would say we are at the, as in state of the mark, state of the art available actuators in the market.
Okay.
And given that we continuously refine it, we would be there close to top at to start with in hardware when comparing against global competitors. The second is software, as in now when these robots are already in the market, they have lots of data. And we are seeing that data is, as in those companies who have collected lots of data, they have lots of experience in deploying these robots, they do have an edge. So what we are targeting is, particularly when we have started working with industries in India, we are collecting data, we are collecting specific use cases in India now to start with, and build applications around it. So we are going the full path of building these robots, deploying these, learning, improving with trial and error, and finally making these robots do useful work.
Okay.
This is the first, as in we are the first company to do that in India. Even there are players, there are Chinese players who have, as in sold the robots, but they are not able to do useful work in India because they have not provided a full stack solution. Robot is one part of the solution. The complete solution comprises of how this robot goes in your factory setup, how that is built around factory, and what kind of data is being collected, how that is being interfaced with a human, and what kind of reports data is being generated when a human is utilizing it in a factory. So all those are, there are gaps in terms of the available robots from the global players at this point. As in there are players who are building the full solution, but they have not sold it in India. So we have been able to tap to that market and build specific use cases and more of a differentiated market in India to start with. And then we tackle similar challenges at the global scale.
Okay, perfect. And talking about the market, since you mentioned a lot of things, so like your positioning, like you mentioned you are bootstrapped and you have generated revenue, you are profitable.
Yes.
Okay, so tell us about that. Like, who are your customers? Like, what is the TAM? Like, everything about market and your positioning.
Okay. So when we started, as in majorly, we have been selling our first version of quadruped robots to academic institutions.
Okay.
And this has served as a research platform. So what our customers can do is they can buy our robots and they can build on top. One of the differences which we can offer is the kind of support and the ecosystem. So we are building a legged community ecosystem here in India. There are not many trained manpower. There are not many, even you go to IITs and NITs, there are not many people who are working on these kinds of advanced robots. So we are supplying the platform so that any research student who is working, their journey is accelerated. They don't have to spend much time on developing their own hardware. And once they have a hardware which is capable of testing their algorithms, then they are developing and learning, and we are also in a way contributing with them to scale the technology here in India.
So as an ecosystem, like we need to evolve, and we are doing that.
Yes.
Okay. And you just transfer the product or tech knowledge and everything, rest of the things too?
Most of the things, because mostly when we sell these robots, there are, we have the commercialized version is at one stage, and then we have R&D which is going on, which is not being transferred outside. So if this is something which got created in 2023 and we are selling in 2024, we already have next version of robots ready for a specific market which is
Okay.
ahead of at this point.
Perfect.
So we can easily, as in we are openly sharing all the information, all the available codes to our customers, which are developing on top. They get full access to the software, and then they get support, technical support from our team, who are providing in a way consultancy or providing support for developing their own code bases. So one of our customers has developed a language interface for these robots or gesture interface for these robots. And since these robots, you especially when you talk about legged robots, they are more as in seen around humans, as in we have created spaces which are as in which we navigate through our legs, right? So these robots can easily be around humans, which mostly the traditional robots like robotic arms, which are heavy robotic arms, industrial arms, as well as big AMRs. They are not supposed to work closely with humans. These robots, in the contrary, are designed to work around humans. So all kind of human machine interface, that is something which our customers are working on, or robots teaming up with humans, robots teaming up with other robots. That is all the different research work and lab work which our customers are doing. And building on that, now as in with those customers and the talent pool that is being created, now we have been more focused on industries. So start of 2025, we got our first industrial customer. So we supplied to Siemens Energy, which is utilizing as in which are also doing research activity in their space for automating inspections in a big factory floor. So what these companies are doing, they are asset heavy companies. So they have lots of assets like gauges, valves, different machines, pumps available in their factory setup, and all those needs to be monitored continuously. They can't put specific IoT sensors at every point. That is again significantly costlier than having a mobile robot which is capable of moving around thousands of assets and continuously collect data. So replacing thousands of IoT sensors installed in a factory to a single robot which carries even expensive sensors like thermal scanner or gas detector with them, and then move around and continuously collect data. So it is helping them to create a digital twin of their environment, helping them to use all the data to do predictive maintenance. So they are now able to make better decisions with all the data, and that we all understand how it will help and modernize all the factories. So that is something which one of our early customers are doing. And then we have partnered with customers in pharma industry who have utilized the robot for automating audits. So pharma and food industries, you will find as in they are more critical in terms of audits and safety as well. So using these robots which don't have to move in and out of a facility, you usually will wear PPE kits or kits, and people will continuously move in and out of facility to perform experiments or to perform as in to move in and out of the facility, right? So a robot which is available there and continuously moving around, automating tasks there, it's significantly advantageous in terms of people movement. So automating audits in a factory. So we helped our customers to conduct a audit, and that was as in they were successful in again, this was again a first in India, that they were successful in they were awarded based on a quadruped auditing their facility, and that was October of last year. And similarly, we are engaging with next customers with our upcoming product lines as well.
Okay, so your products are serving in industries.
Yes.
And your prior customers are like college and research labs.
Yes.
So other than this, like, if you talk about the applications and probable customers, like, are you working with defense or any other government institutions or institutions like that?
So majorly, as in we have with our journey of continuously improving hardware versions and making it more and more capable, we started with our first prototypes in academia. Then we moved to industry, and now as in our focus is more around an industrial grade robot, which is capable of moving in harsh environments, be it higher temperatures or more restrictive environments where even humans are not allowed.
Mm-hmm.
So be that could be tight spaces, that could be spaces in oil and gas industries, wherein you would need PPE kits, again safety equipments to move around, and it could be hazardous. So the idea is uh, our focus would be to build robots which are capable of replacing humans where they shouldn't be,
Mm-hmm.
and supporting humans where they need help in.
Okay.
Oil and gas is one of the biggest sectors where all the our competitors are also focusing,
Mm-hmm.
wherein automating offshore rigs,
Right.
where you have to send an helicopter and a person with it and then do inspections. Routine inspections are also needed in certain spaces. You need unmanned inspections to be done. And these kinds of robots, which are capable of moving in tight spaces, stairs, and as in they're kind of agnostic to any kind of terrain, these kinds of robots play a significant role. And similarly, if I move across defense,
Right, like
yeah,
you mentioned that arm robot.
yes.
So can we just place a weapon instead of that arm, and it can be used in defense or maybe for just inspection or like surveillance or other things?
Yeah. So particularly, as in again, the robot has a particular sensor payload. So we can mount arms, we can mount surveillance cameras, we can mount thermal cameras. All those can be mounted, and it will be able to utilize for any frontline operations as well.
Mm-hmm.
So be it border security and surveillance, be it as in using arms at the front, or even carrying essential supplies in difficult terrains, right? So even supplying medical,
Right.
doing medical supplies at the front line. So that is something which can be done with these robots. So we have been in touch with army for almost as in last 2 years.
Mm-hmm.
We have continuously demonstrated it across all levels in army, be it live demonstrations, working towards their requirements, which is
Mm-hmm.
mostly inclined towards higher payloads. And currently, as in we don't serve towards, as in we are working towards higher payloads. So we have mostly been interacting with them and utilizing, as in getting their requirements and building towards that. One of the as in one of the work which as in we have engaged with certain, let's say, as in preparation projects, in a way that if we are able to achieve certain targets, we would be able to as in get even funding from the army R&D.
Okay.
So that is something which as in we have been continuously been
Yeah,
in touch
like
with.
when you talk about army, like they need the best. So
Yes.
like so do you have any order book from them, or you are just running no cost and no commitment trials and something
At
like
this
that?
point, yeah, we don't have an order book from Indian Army,
Okay.
but we are running no cost, no commitment trials.
Mm-hmm.
We do see significant, as in one of the biggest markets, if I particularly talk about India, is defense. And given China is already modernizing their army with quadrupeds and humanoids, we are working closely, working with army to have those capabilities in house.
Yeah, like everyone is talking like these machines are going to change the landscape of warfare and
Yes.
everything. Like we have seen with lot of operations. Like if we talk about just drones, about in the recent Operation Sindoor and lot of things.
Yeah.
So if we can talk about that, like how these machines are going to change the warfare.
As in, we can see a future with a robot full of,
Hmm.
as an army full of robots, as in all kinds of robots, be it aerial vehicles or
Hmm.
ground vehicles. That too, as in not limiting to
Mm-hmm.
four-legged, six-legged, or even six-legged robots to carry heavier payloads, and humanoid form, where you're carrying weapons, you're able to do multiple operations at once with a single form factor. Along with that, you will see all kind of as in terrain robots, which have belts and those. So army is definitely, as in going towards more modernization in terms of adopting more and more robot platforms. And given that the autonomy is also something which is continuously improving, right? So they carrying a arm at this point, definitely it isn't making any decision of its own and not firing at its own will. But that is something which, as in, we would see continuously being used at the borders. And given that, yeah, China is already progressed a lot, we would need uh, quick action from our end to get prepared for that.
Okay, perfect. So like you're in a lot of no cost no commitment trials and lot of R&D. So business, like tell me about your R&D, like ki how much money you've burnt in like building these machines, or some fascinating stories from building the
Okay.
product or
Okay.
just crashing things down and all.
So mostly, as in, so given that we have, as in, with a limited budget and support from incubators, as in we have been supported by multiple incubators, be it IIT Kanpur, as well as robotics incubator at IIT Delhi, and
Mm-hmm.
ITEL incubator in Chennai. So that was a limited fund which we had utilized in R&D. Now, given that we build robots, we are selling that at a margin of 40 to 50%, and then we are utilizing it completely in operations, be it building the team, be it building next versions of robots.
Mm-hmm.
So I would say, as in, we have not, as in the burn rate has been extremely cautious and minimal, in a way that we have only served certain orders which have been obtained, and we have worked on, as in, we have done limited torture to robots at this point. We can do a lot on these robots, but definitely, as in, we have some funds which are closing, as in, we would close a round in the coming time that would help us to build and break more. At this point, as in, mostly at component level, we have been testing each component. As in, we have testing rigs for actuators, testing rigs for single legs, testing rig of what you see a full robot, and we have been doing extreme testing of these. Outdoors, again, you would see recent videos coming out wherein we are pushing it hard, be it any terrain. So that is something which we are now slowly building on, given that, yeah, as in, we have next 10 orders already lined up. So that is helping us to build and break faster. But before that, I would say, as in, we have been extremely cautious.
Okay. So how many of you sold till now?
We have sold, as in, multiple product lines, SVAN M2 being our prime product. We have sold 5 of these SVAN M2 robots. Again, the first robot is different from what we have sold, the 5th robot, because
Okay.
we have been continuously improving, as in, even uh, in 2 to 3 months, the version of the software upgrades, even the hardware is constantly evolving. So this is one of the versions which is already, as in, we are producing 5 per quarter. There are other product lines like robotic arm, which is again based on our own in-house actuators. So that was designed again with an idea that we need a lightweight robotic arm to be mounted on top. Can we get anything from the market? No, in terms of weight and in terms of the arm lengths, because the function of the arm would be to move at all parts of the ground. It is able to reach all parts of the ground, and it is able to carry a significant payload. So based on our own requirements, we designed a in-house robotic arm, and that, as in, that has been mounted on top. And we have recently launched a new product which is called Scorp. So, and we already have booked customers within, as in, we launched it in January, and we have more than 4 customers booked for Scorp. So be it, again, doing inspections in tight spaces with the robotic arm, which extends its capability. You would be able to see more functions being done rather than just being inspecting. Being an inspector, you are now able to do certain actions. So if there is something of a problem, you can turn a valve, you can turn a switch. So that is an additional capability which we are adding to these robots, so that they're not just mere inspectors, they are able to take actions in the environment.
So is that the robot you're collaborating with ISRO, like to send in the space and collect some particular, like specimens or some kind of things?
At this point, as in, again, particularly as in we have been eyeing towards space as well.
Okay.
So with ISRO, as in there is a collaborative work which is going on with Mobile Robotics Lab at IIT Kanpur and ISRO for working towards a quadruped robot for space.
Okay.
And then we are working with other projects, especially in ISRO for building actuators. So we have already have orders in our account for building actuators for ISRO.
Okay.
So definitely, as in the coming time, we would see these robots, quadruped robots, possibly with an arm as well, going into space and doing. As in, at this point, there would be experimental work that would be done. Again, as in that has been the case with similar projects, and then we do more and more work with these robots.
Absolutely. So just like, a curious question, are you struggling with money like in India, like particularly? Is it too hard for you to raise money, or as an ecosystem, the kind of challenges that you're facing?
Okay. So I would say, as in most of the times, yes.
Okay.
As in, and that has, as in a way, helped us to build a lineup of, as in, generate more customers, generate more
Innovative solutions with low resources.
Yes, that has helped. But yes, it has been difficult early on when we started to convince investors, to convince in investing, which is, as in, again, given that this is something, if I am talking about large scale deployments, we are at least 2 to 3 years away. So given at this point we are only selling 1, 2, 3 robots per year, not enough revenue, but the product is continuously maturing. So we have found it hard for investors to support at this stage with limited industrial deployments. But now, given the current stage, as in we are getting enough with the initial struggle of, let's say, 1.5 years. Now we have keen interest from investors, given our current stage, for investing as well as for scaling it up in a way that this is one of our stable products. We have enough POs lined up, purchase orders lined up, and then we have next versions of robot also lined up for more as in significant deployments in industry. So at this point, yes, there are people who are willing to support us, but not a year back.
Okay, like Deeptech funding has always been like limited in India.
Yes.
Like it is maturing now, but I think government is also supporting a lot of Deeptech now.
Yeah.
So are you getting good support from the government?
As in, again, so mostly the government funding has been directed via multiple
IIT route.
incubators,
Okay.
And as in some of the incubators are getting supported by DST or even corporate funds. So we have received support through channeled through incubators.
Okay, perfect. So Aditya, like, okay, this is the core product for now.
Yeah.
But in the next 3, 4 years, 5 years, like, where do you see this company going, in which direction, or maybe more products or multiple domains?
Okay, so as in one of few of the core technologies which we have worked on, as in that too, is the actuators, the algorithms of how these robots move in different kinds of environments, and recently with autonomous solutions deployed in industries. What we look into, as in we are a focused legged robotics company. Currently, we are building 4-legged robots, and as in we already have lined up humanoid form factors getting built here again, and that too, as in closely working with some army projects. So humanoids, we would like to have our own humanoid built for load carrying capabilities and built for industrial use in construction and as in rated across industry. So you would see it a generalized form factor that is capable of working in different kinds of environment. Quadruped especially, as in we won't be, this isn't something that as in we would continue to work and enhance the capabilities at this point, first with more of harsher environments, starting with industry, and then later towards defense when we talk about from as in coldest of environments to the hottest of environments in Jaisalmer to Ladakh. So robots which does not care about what the environment is, what the terrain is, what the temperature is. We are working towards building robots which are moving in all kinds of terrains. And again, as in I can talk about where xTerra name is coming from.
Okay.
Yeah, so that is the same ideology that.
Is it terrain like?
Yes.
Okay.
So xTerra name is coming from, as an X is a variable which could be anything, and Terra is a word which means terrain. So building robots which are capable of moving in any kind of terrain is what we are focusing on. And at this point with quadrupeds, and as in we have humanoid robots also lined up at this point, as in one of our earlier prototypes is getting manufactured as we talk. So we would be targeting some niche markets and then global markets as well.
So xTerra is a very very cool name. So
Yeah.
what is the X factor of your company? Like ki okay, we are this at this level. Like I think I've seen one of your recent videos. It was super cool. I think so. Where this product lie in India, and what is the X factor of this product?
So, as in first, this is the most advanced robot which is being built in India. As in all the components majorly, except at this point for this robot, batteries and computers, all the products are built and made in India. It is more than 85% indigenous. And the X factor is not the robot, but the team. As in, so
Okay.
it is the members, as in the co-founders and the team which we have built over the years. As in, all it wasn't the case that there are trained people in legged robots in India working in these kinds of fields, and all the workforce which we have developed, almost as in from starting from the research lab to xTerra. This is something that is unique in a way that we are able to solve core problems in locomotion, in hardware, actuators, in partly electronics, even assembling our own battery pack. So we are slowly stacking our tech to build a complete, as in build a complete solution. And with each individual, as in each individual is an owner of a significant chunk of this work, and they've contributed and learned through the path. So it's not, as in few of our co-founders have worked in locomotion field in legged robots for more than 4 years, 5 years now, and building from ground up, solving hard problems from, as in starting deep into mathematics and then building something which works on the ground, right? So our focus has been building something which works on the ground and making it do useful work. You would see thousands of videos of robots dancing around and showing cool moves. What we are focused on is doing useful work in the industry, and being the pioneer here in India, we continue to lead our way to expand and grow our market in India to start with, and then grow globally.
Okay, X Factor is the gun team that you have built.
Yes.
So what drives you and your team on day-to-day basis just doing this? Like, are you guys find this work exciting, or like, what drives you guys and your
Okay.
team?
So, as in all are passionate roboticists.
Okay.
They have worked in different kinds of hardware, robots, building, competing across different competitions in their college days. They have a background in, as in majorly those competitive robotics teams, and coming from that background, they, as in seeing this problem, which is as in particularly a hard problem, that is what is exciting for every one of us. As in we have spent almost 4 months solving a bug and solve it in a day, and then we have worked on as in there are parts which we have worked incrementally and reached to a certain stage which is, as in which is not possible and which is not possible in a short path.
Okay, great, Aditya. Like I wish you and your team like all the best. I hope you guys like create a very great robotics company from India
Yeah.
for the world, and wish you all the very best. And thank you so much for giving me your time and opportunity to feature xTerra Robotics. Any message you want to give to audience or people out there from your end?
I have one message for the audience, as in particularly around a startup journey and especially talking about deep tech robotics. So this is something, as in one thing is you should be clear on what you want to solve and should be passionate enough, because there would be many hurdles on the way. And as in now, with the advent of startups and the culture of startups growing in India, you should only be picking problems which you see solving for next 10 years. If you are particularly interested in deep tech robotics, deep tech robotics. So you should be patient and interested to solve for a longer period of time, and not, let's say, hop from one to another if you face hurdles.
Okay, perfect. And you should be that much talented by yourself.
Yeah, as in, definitely there are people who are learning. There are no scarcity of resources to learn new things, and people building significantly advanced technologies just working from their home. So there is no dearth in terms of the knowledge that can be gained from open sources. You should be passionate enough, and you should stick to a problem to solve a more of a challenging and deep tech problem.
Okay, perfect. Thank you so
Okay.
much, Adit. Thank you so much for your time.
Thank you.
I really had a very great time, and thank you so much for making me learn a lot of things.